Hello, and welcome to Summarize Science. Today, we're looking at a fascinating question. How do we teach computers to truly see and understand the world around them? One of the most common ways is to show an AI millions of images paired with a text description, and then ask it to learn how to generate its own descriptions or captions. But there's a problem with the standard approach. Usually, an AI generates a caption word by word, from left to right, just like we would write a sentence. Researchers found that as the AI gets further into the sentence, it starts paying more attention to the words it's already written and less attention to the actual image. It's a bit like a student who glances at a painting once, starts writing an essay, and then just riffs on their own words without looking back at the art. This paper, Masked Diffusion Captioning for Visual Feature Learning, introduces a clever new solution. Instead of asking the AI to write a caption from scratch, the researchers give it a completed caption, but with many of the words randomly blacked out, as shown in this diagram. Think of it like a game of Mad Libs or a fill-in-the-blanks test. The AI's job is to fill in those missing words, but it can only do so by constantly referring back to the image for clues. This method is called Masked Diffusion Captioning, or MDC for short. By forcing the model to reconstruct the full text from a corrupted version, it ensures that the visual information from the image is used to inform every single part of the caption. So, does it work? The researchers put their MDC-trained model to the test across a variety of standard computer vision benchmarks. They evaluated how well the models learned visual features could be used for tasks like identifying objects in images. The results, shown here in Table 1, demonstrate that this new method is highly competitive with both traditional captioning models and other popular approaches like CLIP. One area where it really shines is with long, descriptive captions. While other methods can struggle to learn from detailed sentences, MDC effectively uses that rich information. It's also much better at understanding compositionality, which is a fancy term for understanding the relationships between different objects. For example, it's better at telling the difference between a dog chasing a cat and a cat chasing a dog, a subtle but crucial distinction that many models miss. The model can also be used to generate new captions for images. As you can see from these examples, by giving it more steps in the denoising process, it can generate longer, more descriptive sentences. So, let's recap the important points. Standard AI captioning methods can lose focus on the image as they generate a sentence. The new Masked Diffusion Captioning method solves this by turning the task into a fill-in-the-blanks puzzle. This forces the AI to constantly use the image as a reference, resulting in a deeper, more robust visual understanding. What could this mean for the future? Well, approaches like this could lead to AI systems that are much better at describing complex scenes, understanding nuanced interactions, and avoiding common errors. It's another step towards AI that can see and reason about the visual world more like we do. That's all for this episode of Summarize Science. Thanks for watching.